burning of a piece of wood is an example of energy changes accompanying chemical reactions. This occurs because the reactants have a higher chemical energy than the products. Bonds break, and new bonds form, and protons and electrons go from a structure of higher potential energy to a lower potential energy. This is known as the potential energy or enthalpy and is stored within the substances such as in covalent bonds, electrostatic forces, and nuclear forces. It's quite difficult to measure the enthalpy of a system, so instead we measure the change in enthalpy. Here's an example. Suppose we dropped 1 gram of sodium hydroxide into 100 grams of water in an insulated cup. The temperature rose from 20 degrees Celsius to 22.66 degrees Celsius. What is the molar heat of solution? The collection of atoms or molecules involved in a chemical reaction is conveniently referred to as a system. In this case, it would be the sodium hydroxide pellets because we're trying to measure the energy released as it dissociates due to the water. Anything else is known as surroundings. In this case, this is the water. It's going to absorb the energy released from the system. Since we're interested in the change in enthalpy, the equation is as follows. Delta H equals the mass of the surroundings times the specific heat capacity of the surroundings times the change in temperature, which is the final minus the initial temperature. Noticing all my units are consistent, grams, degrees Celsius, and joules. We also add a negative sign. This is because delta H indicates a change in enthalpy of the system. The surroundings must undergo an equal but opposite energy change to that experienced by the system. Here's the final calculation. So 1112 joules will be released, indicated by the negative sign, into the solution per gram of sodium hydroxide. But we're not interested in per gram, we're interested in per mole. So, moles of sodium hydroxide is moles on molar mass. 1 gram over 22.99 plus 16 plus 1.008 gives 0.02500 moles. So molar heat of solution is joules per mole. Negative 1112 joules over 0.02500 equals negative 44,480 joules per mole, or negative 44.5 kilojoules per mole.